Hello, my fellow Almontians, and welcome back to another broadcast from the bunker. And a happy Earth Day to you, right? April, what's the date, 22nd? Happy Earth Day, folks. Get out, enjoy the beautiful sunshine, and be kind to Mother Earth. All right, today's hot topic, we're talking about landscapes. How do landscapes differ? We'll go all through those, but before that, make sure you hit the do now. We're doing 17 to 20. And take a look at your homework there, folks. Textbook, read the pages 298 to 313. I'm looking for 15 bullets. It's a good review reading on groundwater that we just covered the other day. All right, so meet me in the GC in a few minutes. Okay, we'll start out on number 17 here. The planets known as gas giants, right? Those are the outer planets. Include Jupiter, Uranus, and which other one? Well, you probably could figure it out. But in just case you can't, you know the reference table chart, the planetary chart toward the back. As you go down the column, you're getting further from the sun. So Jupiter, Saturn, Uranus, Neptune are the gas giants. So go back to your options there. And what's the other gas giant? Hopefully you picked Saturn. All right, for number 18, the average temperature of the planets, well, it's a, process of elimination would be best. Let's see, does it decrease with greater distance from the sun? As you get further out into space, further from the sun, should the planet get colder? Yes, that's probably your best one. No relationship to the distance, that's not true. Depends only on, it's the keyword only, on chemical composition, that's not true. And certainly temperature doesn't increase as you get farther. So yeah, the further you get from the sun, temperature is going to decrease. Number 19, in New York State, which day has the shortest period of daylight? We're talking about the winter solstice there. Shortest day would be December 21st, right? Plus or minus a day. I'm sure everybody's noticing the days getting longer and longer, right? We're approaching the summer solstice on June 21st, plus or minus a day. Okay. And number 20, a comparison of the age of the Earth obtained from radioactive dating, we'll talk about that in the next unit, and the age of the universe is based on galactic Doppler shift, suggests that, well, remember, you can't be older than your mother, right? So if the solar system came from the universe, then the universe, of course, has to be older, and that's what's going on there. So let's run through it. Earth is about the same age as the universe. Well, that would mean that you could be the same age as your mother. No good, right? The solar system and Earth formed billions of years after the universe began. Well, that's starting to make sense. The two dating methods contradict each other. At this time, they do not. And then for D here, the universe is much younger than the Earth. Well, that makes no sense. So we're going to go with choice B. All right, any further questions on those, make sure you leave them down in the YouTube comment section, or, of course, shoot me your questions at Remind. Let's jump to the lesson. Okay. And like I said, today's hot topic is landscapes. Absolutely gorgeous what weathering and erosion do as far as shaping the land. There are also other forces involved, right? Tectonic forces, and we'll talk about those later on as well. So between tectonic forces uplifting and shifting and weathering, erosion, cutting down and carving and breaking, you get all sorts of beautiful landscapes. All right, that's a classic plateau with a flat top with the beautiful mountains in the background. All right, this diagram is in your GC. Take a minute. How many different landscapes do you see, and can you name them? All right, so take a minute, see how many you can fill in there. Hit pause. All right, hopefully you got a couple at least. Let's see how you did. Let's start out up top here, right in the background. You have your mountains, of course. A string of mountains, they call it a mountain chain. All right. Flatter, lower areas are plains. If you have a river cutting through, it's called a valley or a river valley. Smaller than a mountain, but still a bump in the land, they call them hills. These are just some of the landscapes, so hopefully you had those. Your official definition for what landscapes are is right there, right? The physical features of a region on the Earth's surface, such as a hill, valley, streams, mountains, etc. All right, make sure you get that in your notes. All right. However, the best way to see them is from the air. My wife and I took a trip many years back out west to check out the different landscapes. And you can charter a small plane and fly, of course, real low, much lower than the commercial airliners will, and get a real beautiful view of the different landscapes. So check it out. This is in a place called Canyonlands out west. You can see a nice flat top with some pretty decent relief, right? Change of elevation. This area is a plateau. Okay. Here you have a plateau being dissected by a river, so they call it a dissected plateau. And this is the famous Colorado River. It will fly further south. It will flow further south to carve out the Grand Canyon all the way down that way. Here's where two rivers meet. The Green River meets the Colorado. You can actually see the Green River. The green is from some greenish mineral, if you remember olivine, right? Being transported there in suspension. And of course, the orangish Colorado is because a lot of clay is held in suspension. And the green is a tributary. It contributes water to the Colorado. And then the two flow, they become one, and they flow down south once again to cut out the Grand Canyon. Just to give you a reference there for scale, that's over 1,000 feet tall, folks. That's tall, as tall as the Empire State Building. So you're talking about serious erosion with that river carving it out. Here's another one. This is called the Paria River. It's a tributary to the Colorado. Again, it contributes to it. And you can see it starts out on a plain there, but then it starts to carve out a canyon. And when you turn the plane around and fly the other way, you see the beautiful Bryce Canyon. Bryce Canyon was not fully carved out by the river, however, mostly formed by frost action and weathering from rain. Of course, the river helps that. But this is just one of those gorgeous places out west that I hope you get to see sometime in your lifetime. All right, keep flying. What do you see? What kind of landscape? Well, maybe you just see a giant lizard. Yes. Mother Nature has a funny way of carving things out that looks like a giant lizard there. I mean, you can see a giant crocodile. All right, this again is a dissected plateau. Or maybe you see a submarine in the desert. Kind of strange, right? Yeah, that also was carved out through weathering and erosion. All part of that dissected plateau. All right, so truly beautiful landscapes. Those were only a couple, of course, throughout the United States. Well, how do these landscapes develop? All right, make sure you get your notes in there. First off, we'll start off with uplifting forces, right? Tectonic forces push the earth up. And that's how you get those gorgeous high mountains. Mother Nature, of course, chops them down and it sculpts them, makes them beautiful. But you start with an uplifting force. All right? Then the leveling force we just talked about, right? Weathering and erosion, chopping it down. And the two are in balance. And if the elevation stays about the same, they say it's in equilibrium. But usually it's either going up or coming down, constantly changing, evolving over time. Okay? If the rate of uplift is equal to the rate of erosion, then it's said to be in equilibrium. All right. How would you describe these landscape regions here? Well, this is a highland, a mountain, extreme relief. Very, very high above sea level. You'll get folded and tilted rocks, which often metamorphoses them, right? You'll find lots of banding, right? Metamorphic rocks. Extremely steep slopes. If you're into snow skiing, of course, you head to the mountains, obviously. All right. This little different area, again, that's what we saw from the airplane, right? That's your dissected plateau. You can see the flatter tops. They call these plateaus, and they can still be pretty high, right? For example, the Catskills, you've probably heard of that. A lot of people say the Catskill Mountains. No, those are a plateau, but some of those are over 3,000 feet high, right? So they're quite enormous. You get usually horizontal rock structure, right? It hasn't been tilted or folded, so you can still have lots of sedimentary rock. As the river cuts deeper, right, you're getting deeper into the earth, older rock. You can find older fossils, and because it's sedimentary rock, the fossils are preserved. Okay? And then, of course, you get to the lower flat areas, right, the plains. And they tend to be older areas, lower relief, lots of sedimentary rock. You could have small hills, right? You've heard of rolling plains. But overall, it's a pretty low elevation, closer to sea level. All right? Make sure you're getting all this in your notes, folks. Then you flip to your reference tables, and there'll be a whole 2 maps dedicated to the landscapes in New York State. You can see mountains in the northwest. There's the huge Allegheny Plateau with the Catskills connected to it. That is still a plateau. The Erie, Ontario lowlands on the shores of Lake Ontario, which separates us from Canada. Then if you head down toward where we are, right, you cross a lowland, which is a plain. Then you go up to the Taconic Mountains, and eventually the Hudson Highlands, Manhattan Prong, to the Atlantic Coastal Plain. That's right, folks. We live on a plain, a coastal plain. We call it Long Island. But that's the landscape we live on. Now, they could ask you what type of rock is in any one of these places, and all you got to do is overlay the other map that's in the reference tables. It looks like this. Now, I know that's kind of crazy, but now all these different patterns represent different rock types, and the key is down here. So I'll zoom in on that key. What type of bedrock, for example, is in the Allegheny Plateau? Well, that's here. You got a lot of polka dots. And the polka dots tell you right there, it's limestone, shale, sandstone, so it's dominantly sedimentary. It'll also tell you how old it is, right? Devonian is an age in Earth's history, and we'll talk about that again in the last unit. But Devonian aged rock is upstate. And New York State, as you can see, has lots of different landscapes, lots of different rock types, and of course, rock ages. It's a pretty amazing state. All right. How does climate affect our landscapes? Well, I think you can tell on the left side, this is getting a lot more rain, a lot more moisture. It's very humid, and the slopes are much more rounded. Whereas on the right side, you're a more desert climate. It's more arid. You have much more jagged slopes going on, totally changing the look of the land. All right? So your humid climate makes it smooth. That's the one on the left. And, of course, your arid climate on the right. Now, the regions diagrams, they make them look similar to this, right? Of course, they're not as pretty. But these are your classic regions diagrams for a humid area landscape and a more arid landscape. Okay? Notice the horizontal bedrock underneath, which means that both of these are a plateau. Very good. Okay. Okay. Can you determine the path that the water will flow on these landscapes? So here are 4 pictures. You have to realize, all right, which way will the water go? Well, we know water always goes downhill. So over here, where is uphill? Well, it seems to be higher here. So the water should flow down, down, down like this. And you get this pattern called dendritic. All right, a dendritic pattern flowing over the land. Look at this one over here. This obviously is the highest point. So wherever it rains, and we did this with contour mapping a while back, the water will go down always from that center point. And that's called a radial pattern. Over here, oftentimes when you get earthquakes, the earth will shift and make these right angles, and a river that used to flow straight will now take a right angle turn, and they call that rectangular, right? Rectangles have right angles. And the last one here, this one you have hard rock, followed by soft rock, followed by hard rock. And hard rock doesn't weather as quickly, so it stays higher. The soft rock weathers faster, it goes lower, and you get this crazy looking pattern of water flowing. They call that a trellis. All right. Now these patterns of water flowage are called stream drainage patterns. So on the next slide here, it's going to say, all right, well, can you match the stream drainage pattern to the landscape? The patterns are on the bottom. The landscapes are numbered. So this is giving you a top view. This is kind of more of a 3D side view. Can you match them? All right, take a minute to do that. All right, hopefully you put some good effort into that. For the first one here, it looks like a hill of some sort, a mountain. So wherever it rains, the water will go out in all directions. That's your radial, and we'll overlay the pattern there. So maybe you want to sketch that into your notes. All right. For the second one, what will that look like? Well, the water will kind of flow in circular paths there. So you're going to go with your annular, like the annular rings of a tree. That should kind of resemble that to you. The next one over here, the third one, if it rains on there, what will the water look like? Well, that is your dendritic. It'll be like the hand. It'll kind of all come down to a central point. These are all called tributaries, by the way. And the tributaries contribute water to the central river. The last one, obviously, process of elimination, choice 4, your trellis. And again, that's alternating hard rock, soft rock, hard rock, soft rock, hard rock, soft rock. And you get that cool pattern, that stream drainage pattern called a trellis. All right? So look that over again. Make sure that makes sense to you. A couple of summary questions. This is a portion of the Grand Canyon, right, carved out by the Colorado River. Notice the horizontal bedrock. So this region must be which type of landscape with horizontal bedrock? Well, hopefully you chose a plateau. Okay, the Colorado Plateau, believe it or not, the river has carved down several miles at this point. It still has a ways to go before it gets to sea level, but it has made the Grand Canyon over a mile deep already, and it's still flowing strong. Okay. Next summary question here. Which factor is primarily responsible for causing these different drainage patterns? Why does the water travel these different ways? Well, hopefully you connected that to landscapes, right? The structure of the bedrock or the landscape. Water always goes downhill, so whichever way downhill is, the water will flow. And that is not always south, right? South could be uphill. It just depends on the landscape orientation. All right. Hopefully that made sense to you. If you have additional questions, you guys know the deal. You can type them in the YouTube section, or of course send your questions to Remind. All right. Get outside and enjoy this beautiful day. And again, happy Earth Day to you folks. See you next time.